All right. Hello, everyone. So, this is the walkthrough for Lab 1 in the Survey of Chemistry 1151 at Columbus State University. I'm John Geary. I'm the online instructor for these lab courses. And I'm going to kind of walk through the entire first lab just to make sure that everybody's on the same page and that you get everything submitted correctly. Okay? So I apologize for this being a little late. We've had a ton of problems with Chem 21 and still having problems. So if you are unable to log in for whatever reason, it says you need to be enrolled or whatever, send me an email. Let me know where you're at. I know I've probably talked about 30 or 40 of you already, and we've been trying to work this out. Just keep trying to log in. If it doesn't let you, send me another email. I might have to delete you and then re-add you. For some of you, I had to set a password. Some of you have already logged in and set your password, and now you still can't. Now you can't get back in. Those are the ones that I'm probably going to have to delete and re-add. So just let me know where you're at if you can't get into the program. If you're in the program, fine. I don't really need to hear from you unless you're having issues with something else. Okay. Uh, but as for questions about Chem 21 and how to submit assignments, how to open the lab worksheet, how to do anything in the lab, I'm going to cover all of that today. Okay? So, first off, before we go into Chem 21, I want to show you Cougar View and what you can find there. So, I have created PowerPoints. Both of these Lab 1 chemistry and measurements are PowerPoints. One of them is a PDF version, one of them is in a PowerPoint version. So, if you want to use the PowerPoint version, you can download it and then load it into your Microsoft Office or PowerPoint. Okay? The PDF might not allow you to click on some of the links, but it's easy just to click on and view and scroll through like this. Okay? It might actually, yeah, it might let you click on all these links. So I've also included links to YouTube videos. Some of them have the videos embedded in the PowerPoint, and I will play those for you later on today. If you would like to play them yourself, you probably need to open the PowerPoint version, right? This PowerPoint version, open it in your own PowerPoint program or in Microsoft Office online, and you can view the embedded videos. But I've also provided the link, so if you just want to copy and paste the link onto another page, you can do that as well. Okay, so this PDF document on the bottom is a copy, I repeat, copy of the worksheet and PDF that you'll get from Chem 21. Okay, so this is just for you to have. It's not necessarily where you should be filling out your answers. Okay, all of the answers are submitted on Chem 21. Make sure y'all can still see me. So let's see. Let's do class files. No, let's not do that. Let's choose one. So today is Lab 1 Measurements in Chemistry, and I'm going to click on Work Assignment. So this should show up exactly how you see it. Let me make sure you can still see what I see. Okay? This is where I got that PDF lab guide, so you can click on that, open that up, and it'll have all the information like your pre-lab. We're going to go through all this here in a minute. Uh, but I just want to make sure everybody knows where everything is at. Okay? So that's that. Now, when you get ready to start submitting answers, you just have to start from the top, okay? Because it goes through, make sure y'all can see what I'm seeing. Yeah, this little submit and next problem on the right, it's not going to let you move forward if your answer is way off, okay? So it's going to stop you, and I believe you can't even jump around or anything until after you've completed each section, okay? So you're going to start at the top. You're going to submit answer under this first little part that says write one sentence purpose statement that details the experimental purpose of this week's lab. If you're wondering what that is, go back to this PDF guide, right? It talks about the goals of this lab. So everything you need is going to be located somewhere, all right? Either in the PowerPoint or on this sheet, or I'm going to talk you through it, okay? So then you'll go in there, you'll type in your answer, hit submit, blah, blah, next problem, and now you'll see that it opens up all of these other spaces for you to enter answers for the next few problems. Okay? Now, where do I find what they're asking for? The volume in milliliters and a 10 milliliter graduated cylinder. Okay? This is where we're going to do the PowerPoint. All right, so I'm going to walk through each of these problems on the PowerPoint, and I'm going to show you what images and which videos you need to use for each section. Okay? So once you've completed all of this and you've submitted all of your answers, I will have a copy of your work. Okay, so I'll be able to go in and grade everybody's work directly here on Chem 21. So you're not filling out, in the past in my labs, we filled out lab report sheets and then had to upload them like you did the ACS worksheet. And so that created a lot of grading, extra paperwork, a lot of work on your end to take a picture or upload a PDF or all of these different things. Chem 21 strikes out all of that. And also you had to pay $30 for the lab manual. So this is only 20 bucks. It's an online program. It's going to be much more efficient, much easier for me to grade, and much easier for you to do. Okay? But basically all the experiments are essentially the same. So, with that being said, I think that's covered everything as far as the introduction to Chem 21. Just let me know, like I said, if you haven't gotten access yet, this assignment is due by this Sunday at midnight. So make sure you go ahead and get in there and get all of this done. All right. So that's it for this introduction. I'm now going to go to, let's go to the sheet first, and then we'll work on, I'll go to the PowerPoints. Okay, so just some safety. You're not coming into the lab, so safety is not really a concern for you, but just so you know, you should always wear closed-toed shoes, and your ACS worksheet should have covered all this. Closed-toed shoes, long pants, um, gloves, and goggles. Okay? So that way, if anything splashes up on your skin or in your eyes, you're safe. You need to be aware of any sinks or showers that you can get access to in your lab area. So in case there's a fire or you get something on your skin, you can wash it off as quickly as possible. Okay. Yeah. So this has a lot of information, a kind of a pre-lab introduction, so to speak, but we should have covered, most of you have covered this in your lecture course, and you should be already at this point in your lecture course. All right, so I'm not going to spend too much time on each of this individually, but I did put a few things in the PowerPoint that I kind of want to talk about. So let's go there. This is the PowerPoint that I provided in Cougar View. Let's go to present. Okay, so lab one, measurements in chemistry. Scientists in general, so physics, chemists, biology, uh, pretty much all the medical sciences, anything to do with that, they're going to use the SI system of units. And the reason we do that is though that whether we're communicating with doctors from India or England or America or anywhere around the world, we're all on the same page as far as units. So we set up this based on the metric system because it was already the most widely used and makes the most sense. If you'll notice that the English system can't use the things that we use in the metric system, such as prefixes. So these are the different units, the SI units, for time, length, mass, etc. Um, but the great thing about the metric system is the ability to use the prefixes. Okay, so a prefix system allows you to get to write very large numbers or very small numbers in an efficient way. An efficient way. So efficient, by efficient I mean if I had to write 18 zeros, or let's say 12 zeros for a terabyte every time I wrote out a value, that would take a lot of time. Not very efficient. So the efficient way to do it would be able to say 1 point so and so, scientific notation, right? 1.25 times 10 to the 12th. So it's 1 terabyte, but I didn't have to write 12 zeros out, right? So the prefix system also allows you to move back and forth between units. So if somebody gives me a measurement in meters, but I need it in centimeters so I can figure out the volume, I can convert that just based on this prefix system, right? The English system, measurement system, doesn't have this. You can't do a centipound or a millipound or anything like that. And so that's why the metric system is a much more useful system when you're doing scientific data, right, or anything like that. The metric system is, uh, in my opinion, much easier, right? Because and it also goes by powers of 10, which makes it easier, right? So like there's 12 inches in a foot, or 3 yards in a meter. None of these are kind of just arbitrary numbers that there's no consistency to them. Everything in the metric system goes by factors of 10. So 10 millimeters is in a centimeter, 10 centimeters is in a decimeter, 10 decimeters is in a meter, so on and so forth. Okay? And so all of these things make it easier to use the SI system as a metric system. And then I've also provided links in case you don't know how to go back and forth between different prefixes. Um, I provided this link. You can go there, and it's a short little YouTube video explaining prefix conversions and those type of things. Okay. So we've also covered some of this in lecture, but I'll kind of reiterate it just to make sure everybody gets it. Exact versus inexact numbers. So an exact number would be as if I was counting, like say a number of people, right? I can't have a half a person, so when I go to count people, there's always an exact number. When I go to count pretty much any objects, like in counting numbers, it's going to be an exact number, okay? And there's several other examples of where things might be exact numbers, means there is no half or there is no ambiguity. Ambiguity meaning that if two different people look at this object, they don't come up with two different numbers, right? So that would be inexact numbers. Measurements, for just a general rule of thumb, are inexact measurements. I can always take a measurement to be more, to have more or less significant figures, right? So let's look at this line down at the bottom. Um, 3 different people come up to this line and try to read the measurement, right? One person might say it's 5.75. One person might say it's 5.9. One person might say it's 6, right? There is some ambiguity to a measurement, and that's why we call them inexact numbers. So what we've done is create this system where everybody can kind of follow the same rules, right? So before I go on to that, let's talk about precision versus accuracy. Um, so precision is throwing a dart at the dartboard and all of your darts being very close to each other. Okay, so this bottom right, for example, would be a precise throw or a precise measurement. You took the measurement 5 times, and all 5 times they were very close to each other. That is precision. Accuracy is how close it is to the actual value. Okay, so that's whether or not you're right or wrong, is how accurate you are. Okay, The goal of science is to be as accurate and as precise as possible. When you do measurements, you want them to be repeatable, right? That's why we say we like precision. You need to always round. If I'm reading off of this ruler, I need to always round to the same digit every time I measure. If I'm rounding to a tenth of a centimeter, then the next time I take a measurement, I need to stop at a tenth of a centimeter. Okay? So that will create the precision. Now, accuracy is just how well you how well you're doing the measurement, right? Um, as I said, somebody might say that that's 5.75. Somebody might say that it's 6. Me personally might say that it's 5.90. So I would be more accurate than the person that said 5.75 or 6. And then once we took multiple measurements, if he did 6, 6.1, 5.9, and I did 6.90, 6.90, 6.90, his are kind of hit and miss, like this top left bullseye here. They're all pretty close, but they're not as precise as mine would be, is hitting 6 point or 5.90, 5.95, 5.90. Mine, those values would be more along the example of the top right, precise and accurate. All right, so that's the difference in precision. Precision is being able to hit the same spot multiple times, right? Your values are very close to each other. Accuracy is how close you are to the actual value, okay? How right or how wrong your values are. So, significant figures you should have addressed in lecture. Significant figures are all counting whole numbers, zeros behind the decimal, zeros in between whole numbers. And then you should, when you add, subtract, multiply, divide, you should follow the rules of adding, multiplying, subtracting, dividing significant figures. All right, so for those of you in my lecture, you want to make sure you've reviewed that before you go into here and start conducting this experiment. Okay? So now, last thing I'll talk about before we get into the actual lab is what an estimated digit is. Okay, so when I was talking about the ruler here and giving you examples of how people might say that that line is a different length, different people might see it a different way, might not understand how to read a ruler correctly, or may get confused about which side of the line uh, it ends at. Okay, so what we do is we add a zero or a 5 to any increment that you can see. Okay, so let me stop there, say it again, and kind of show you a couple of examples. When measuring a value that is on a scale, like a ruler or a graduated cylinder, you want to include as many significant figures as possible. Okay, if I just call this line 6 centimeters, I only have one significant figure. So when I go to start doing my calculating, if I have to use this for something, that will limit my final calculation to one significant figure. So scientists, we've come up with another method to add significant figures and be more as precise as possible when measuring on scales like this. Oh, excuse me. All right. And so the way that works, let me pull up my paint program real quick. Paint. Okay, let me see if I can insert an image. Oh, I apologize. Okay. I'm just going to kind of draw. Well, can I do that? Let me see. Why is this so big? Alright, I apologize. I was trying to do something to show you, but that's not gonna work, I don't think. Alright, let me go back here. So this ruler has the line ends at about 5.9. Remember, each one of these little notches is a tenth of a centimeter. So 1 millimeter or a tenth of a centimeter. Let me make sure y'all can still see me. So an estimated digit. Oh, sorry. An estimated digit is always the last number of the measured value. Okay, so we always add one significant figure. It'll either be a 0 or a 5. Okay, every time. If this line, I'm looking at this purple line, falls directly on the increment, the millimeter, 0.90, if it falls directly on that line, I'll call it 90. If it was in between the 8 and the 5, which some of you might see it as in between the 8 and the 5, or excuse me, the 8 and the 9, I'd call it 5.85. Okay, so either 5.90 or 5.85. Adding that extra zero point 0 or zero point 0.5 um, allows you to increase the number of significant digits. As I said, if I just called this 5.9, it would only be two significant figures. If I just called it 5.8, it would only be two significant figures. So what you will do is add either a 0 or a 5. Uh, doesn't matter what the scale is, okay? If this scale is going by, I'll do another one with a graduated cylinder. Um, but most of them will go by either ones or a tenth at a time. So you're going to add a 0 or 5 no matter what, okay? If it's, let's say it falls directly on the 6, okay? That would be 6.00. All right, if it was in between the 6 and the 6.1, say right here, then I would call that 6.05. Okay? And so you're expected to have as many significant figures as possible. If you go to your program and try to write 6 centimeters, it'll probably tell you that you don't have enough significant figures, or it'll mark the first answer incorrect. So you need to make sure you always include those extra significant figures. Let me look at a graduated cylinder real quick and kind of show you another example of how we look at scaled measurements, right? And when I say scaled, I mean it's in a device or a ruler or a beaker or a cylinder, some way that we can measure a volume, a mass, a length. Okay? And I shouldn't say mass because mass is not on a scale like that. Uh, it gives you a value, and that's what you write down. So let me do graduated cylinder. Images. Alright, so let's look at one that actually has some water in it. I like this one. Okay, so this is going in increments of 1 milliliter, right? That's 20, actually it's by half a millimeter. So this one will be 15.5, that'd be 16, 16.5, 17, so on and so forth. Make sure y'all can still see it. Yeah. Does that get any bigger? Nope. Okay. So, as I said, you would add a zero point 0.5 or zero point 0, essentially just splitting those increments in half, right? If it's right in between the two increments, you'll split it directly in half. Let's say, for example, let's see, this line, I would say falls right in between 16 and 16.5. Okay? Wait. Yeah, between 15.5 and 16. So directly in between that, let me pull up Paint again. Alright, so my value is in between 15.5 and 16.0. Okay, make sure to include as many significant figures as you can. Alright, so now what's directly in between that? 15.75. Right? So just like that, I've added another significant figure, and it is more precise and more accurate than it would have been had I said 15.5 or 16.0. Okay, so it's both more accurate and more precise at the same time. So that's how come we add that extra significant figure. Let's say that this is falls directly on the 16. Okay, so I would call it 16.0. Probably wouldn't add another zero there just because the scale is kind of messed up, but you could. You could add 16.00 if you feel it falls directly on the line. Let me look at another example. So most of the times they'll be in increments of 1. Let me find something with some liquid in it. Yeah, so this one is in increments of 1, and if it fell, that one falls directly on the line, I would call it 35.0. Oh, sorry. So this one goes by increments of 1. Most of the graduated cylinders you will deal with will go by either 1 or zero point 0.1. Okay, so either way, you're trying to add a significant figure on the end. This one I would call 35.0. If it were a little bit higher, I might call 35.5, but either way, you're always going to get that one extra significant figure, whether you're talking about on a ruler or in a graduated cylinder or in a burette, which you haven't seen yet, but we'll talk about later. Okay, so that's the estimated digit. The last one that you see of a measured number is always the estimated digit, and you can just assume that we've estimated there because, as I said, measurements can always be more precise. Right? I can always get a device that measures more accurately and has more precision, and then that device would tell me it's actually 35.056 milliliters in this cylinder as opposed to the one that I'm using, which I can only tell if it has 35 or 36. Okay? So, anyway, that's the estimated digit. Let me go back to PowerPoint. Okay. So now we are in Chem 21. I'm going to go back to Chem 21. We are at part A, measuring volume. So you will edit this answer based on the PDF guide that I provided and Chem 21 provides. Now, when you get to these, all the parts in purple, I believe, or pretty much everything from here on out till you get to the post lab questions, okay, is going to be in the PowerPoint. So you'll pull up the PowerPoint. This will be part A, measuring volume. Right, oh, let me go back up. Part A, measuring volume. You see I've labeled it at the bottom, 10 milliliter graduated cylinder. So you'll need to read the volume in this graduated cylinder. Remember to read the meniscus. Okay, so on a meniscus, come back to me. Actually, I'll show you on the internet. That'd probably be easier. Transition, meniscus, graduated cylinder. Okay, this is a good one here. Okay, you see how the curve of the water goes down? You always want to read from the bottommost part of that curve. Okay, here's another good example. So this one right here, these are increments of 1. So that's 21, 22, 23, 24, 25, 26. It's in between 25 and 26, so I would call this 25.5. Okay? Always read from the bottom of the meniscus. That's what this little curve in the water is called when it's in a graduated cylinder. And you'll see that pretty often because uh, the forces of the water kind of hold it to the edge and let the bottom fall down a little more. All right, so let me go back to Chem 21, make sure we're on the right part. All right, so I'm here, I'm entering the volume in milliliters of a 10 milliliter graduated cylinder. I go back to my PowerPoint, I see that this is my 10 milliliter graduated cylinder. So I can read this value, bottom of the meniscus, give you an estimated digit, right? Add that 0 or 5. Looks like here is 6, 1, 2, 3, 4, 5. That's 5. So these are going by a tenth. So this one would be, if it was right on that line, I'd call it 6.50. If it's right in between, I call it 6.55. All right. So I'm kind of go ahead and giving you this first one. Whichever one you decide is fine. I think you have a little bit of error, but make sure you read things the same way every time. If you tend to favor going up, always favor going up. If you tend to favor coming down to the one below it, always favor coming down below it. Be consistent and your answers will be consistent as well. Okay? So next up is the 25 milliliter graduated cylinder. And so you'll transition back over here, put in the value that you read that flask at, that read that volume at, and enter it into your information here. Okay, keep going. That's the 50 milliliter graduated cylinder. You'll do the same thing. Now we're going to talk about displacement. Okay, bring just me up here. Okay, so displacement, for those of you, I think we ought to cover this in lecture, but if we didn't, here it goes. Archimedes was a great mathematician, and he had the idea, he sat in his bathtub one day, sat back, and the water level started to rise. Okay, and so he said, well, how much did that water rise? How can I figure out how much difference the water level is between when I got in and when I got out? Well, it turns out, and he theorized this and was correct in doing so, that the volume of the object that I put in the water is the same volume that the water was displaced. Okay? If I have a 10 liter box, okay, and I pressed it into a bathtub and I pressed it till it was fully submerged, right? Just the box was under the water level will raise by 10 liters exactly. Okay? So that's what displacement is. Displacement is saying that water moves by the same volume of the object that's inside the water. Okay? So that's how we're going to do this next part of the experiment. I'm going to give you an initial volume of water in a graduated cylinder. I'm going to give you a final volume of water with an object in there, and then you're going to tell me the volume of the object. Okay, remember volume is either in milliliters or centimeters cubed, but it represents a space, an amount of space that some object takes up. So displacement is what we use to kind of figure out the volume of irregular objects, objects that can't be measured length, width, height, like a box. Okay, remember volume of a box is length times width times height. So if this was a square object, I could figure out roughly about the volume of it. But since it's not, it's kind of cylindrical, I have to use a graduated cylinder, and we're going to use displacement of water to determine the volume. Okay, so what you'll do is you'll enter in the initial volume on your worksheet in Cougar View, or excuse me, in Chem Labs. You'll enter in the final volume in Chem Lab, and then you will subtract the initial from the final. Okay, the final volume is always going to be higher because that includes the water and the object. So final volume minus initial volume will give you the volume of the irregular solid by water displacement. That's this part here. Okay. So yeah, make sure that you have estimated digits as possible, right? That you're as precise as possible, and then that way you'll have as many significant figures as you need to calculate in the end, right? If I do 25.0 minus 20.0, that'll be 5.0, right? So I only got two significant figures in the end there, but adding that point zero for both of the first values allowed me to have that extra significant figure at the end. All right. Let's go. Let's keep going. So that covers part A. All right. For part B, we're going to measure the length of a box, both the length, the width, and the height. Right. And so as we said, if you have the length, width, height of a box, you can calculate the volume. Okay. So, an interesting note: I couldn't get my computer to put a subscript on this PowerPoint. I don't know what happened. But a centimeter cubed is the same thing as a milliliter. Okay. So when you go back, oh, sorry, don't save. When you go back to your worksheet, you'll see that it wants you to report the width, the length, the height, all in centimeters, but then it asks for the volume of the regular object, centimeter cubed. Okay, so you want to express this as centimeter cubed, but it's important to know that a centimeter cubed is the same as a milliliter. Okay, uh, we actually came up with the milliliter based on that dimensional analysis, right? 1 centimeter, 1 centimeter, 1 centimeter. This little cube is exactly 1 milliliter. So that's another one of the reasons that the metric system is so much easier. All of these values are convertible, right? Essentially. So either way, this is the images for the part that you'll need in Chem 21. I hope I don't confuse anybody here, but you'll go through the measure and length portion. You'll enter in all the different values from the PowerPoint, right? This is the height, that's the length, that's the width. Make sure to add an estimated digit, right? So just looking at this one kind of from afar, I'm not going to get too in depth with it, but I'll just say 4.50, right? Uh, I'm saying it lands directly on this line. It obviously doesn't, but I'll call it 4.50. That adds the estimated digit, the zero at the end of my uh, measured value. And so then I'll have more significant figures in the end when I calculate the volume. Okay, measure the width, and then all three of those together, length times width times height, will give you the volume of the box. Okay, so that's all you do for part B. Let's keep going. Alright, so for part C, I've included this video. I'm going to watch it with you here. You will be recording, go back to Chem 21, you will be recording the mass of metal cylinder A and metal cylinder B. Okay? So let me go here and let's watch that real quick. She's tearing the balance there to zero it out. That's called tare, T-A-R-E. Here is metal object A. So enter in that value, as many numbers as the scale gives you. Always include all the numbers, as many significant figures as possible is always a good thing in science. Alright, there's object B. You see they're roughly about the same size, but much different in weight. So make notes of those on your Chem 21 report sheet here. And then that's it for part C. Let's see. And now here's part D, measuring the temperature of waters. Okay, and like I said, I've also included the link here in case this video doesn't open for you, but I'm going to play them for you so you have, you can always come back to this video if you want. So just in case you can't see it, there is a decimal there. So I'm looking at 53.5, 53.7, blah, blah, blah. Okay, so just make sure you know that there is an extra decimal there. It's not 538, it's 53.8. Okay? And I think that's it for the PowerPoint. Yeah, that's it for the PowerPoint. Let me make sure there's nothing else on Chem 21 that we need to cover. Okay, so just so you're clear, the initial temperature was given in Celsius, all right? But then we also asked you to convert that into Fahrenheit and Kelvin as well. Okay, so make sure that for those of you in my lecture, we covered a little bit of this and I included some videos. Uh, but you can also, I'm pretty sure, just look on the internet. If you don't know how to do the conversions, you can just type in, hey, this is my temperature in Celsius, what is Kelvin, what is Fahrenheit, and it'll give you the information. I wouldn't recommend that. I would recommend knowing how to do the math because I am going to quiz you on this on the midterm for lab and lecture. So it's good for you to know how to do these conversions, but caveat, you can always look them up, right? I very rarely remember, I mean, I do remember a lot of conversions, like 2.2 kilometers is a mile, but if I want to know how many kilometers this a 5K is or whatever, I'll probably just type it in and say how many miles is 5K, right? So, uh, just a little caveat: don't be scared to be resourceful. Okay, that's what I'll just leave it at that. All right, and then last up, you got post lab questions. These are questions that are provided by the program. We don't do we just grade them. Okay, so these are just straightforward questions, probably very similar to what you might see on the midterm or the final. So go through there, answer those, take your time, get them right. Email me if you have any problems. All right. So once you're done with all of this and you've submitted your data on the last problem, it will automatically give you a grade for portions of it. There will be other portions that I'll have to go back in and look at or maybe give credit back for certain things. All right. So you'll have some instant feedback right when it starts, or excuse me, right when you finish, but it's not entirely completed yet. All right. So don't worry about your grade as much there. Uh, I usually catch up on grading later on in the semester. You'll have a good idea of how well you did, though. Okay, because I mean, the written answer, most of everyone is going to get that right. So you can just go ahead and add those points in. You probably did got 100 on that section. Um, Other sections might be a little more ambiguous. Maybe you didn't have enough significant figures, so you only lost partial credit, stuff like that. Okay. Uh, I think that's everything I needed to cover for today. So if you think of anything that I missed, or if you have any other problems, if you still can't get logged into Chem 21, I know I'll probably be doing that a lot more today for the rest of the day or in tomorrow too. Let me know that you're not enrolled, and I can try to figure out how we can get you in there and get you to where you can see all of this that we're doing. Okay? So just real quick, to kind of finish up, review, and make sure that everybody's on the same page. I've posted the PowerPoint is in your Cougar View under Content Lab 1. I posted both a PDF and a PowerPoint. If you want to just watch this video again, you can, and I go through all the PowerPoints. But if you want your own version of the PowerPoints, I have both the PDF and the PowerPoint. Uh, if you want to be able to use the links and everything efficiently, you might need to open it in PowerPoint, the actual Microsoft PowerPoint program. You can do that online through Microsoft Office, or if you have Microsoft Office or Microsoft PowerPoint on your computer, you can download it and open it through that. And then everything else is done through Chem 21. So when you go into Chem 21, log in. We're on Lab 1. All of this is due by this Sunday at midnight. Okay? So that's it. I will see y'all next week for Chapter 2 and Lab 2. See y'all later.